Today we're talking about tree diagrams, and tree diagrams is essentially a useful way of showing the outcomes of possible events. So let's say that I'm going to toss a coin 3 times.
Is this for YouTube?
Yes. So 3 times. So I'm going to have 1, 2, and the third toss. On the first toss, I can have heads or tails, right? So this is my first toss. I can have toss 1. I'm going to rewrite it a little bit differently. So on number 1, starting over here, there are 2 outcomes. I can have heads or tails. So this is my experiment, and on this experiment I can have 2 outcomes. The first one is heads, the second one is tails. So on the second toss, if I get heads on the first toss, how many outcomes are possible for the second one? 2 again. I'm tossing a coin, so there are 2 outcomes possible. Heads and tails again, that's right. So I'm going to have 2 possible outcomes over here. Let me move this a little bit. So if I got tails on the first one, on the second one, again, I can get heads or tails. So heads, tails, heads, and tails. Okay? So that's the second toss that I have. And now, first one, the second one, and on the third one, I can have, again, if I got heads on the first one, I can have heads or tails. Heads or tails on the third one. If I got tails on the second one, I can have heads or tails on the third one. Heads or tails. If I got tails and then heads, I can have again heads or tails. And finally, if I got tails and tails, again, heads or tails. So now this thing sort of, kind of should resemble a tree in an ideal situation. So let me move this a little bit. Should resemble a tree, and that's why it's called a tree diagram. So any path that I follow along that tree is a path that the outcomes could take for the 3 coin tosses. So this is the result of the first one, results of the second one, and results of the third one. So I could have heads, tails, heads, or a different path. I could have tails, heads, tails, and so on. So what I'm going to do now, I'm going to list all possible outcomes for the 3 coin tosses, which means that I'm going along the path, all the paths that are possible. So starting from the start, up here, up, and up, I'm getting H, H, H. Then the next one, along the same path, up and up again, but now I go down because I already covered this path over here. So the outcome is heads, heads, tails. That's another possible outcome. So another path, I can go to heads on the first toss, tails, and then heads. So it's H, H, T, H, T, H rather. Then going on along the same path, heads, tails, and then I'm getting tails. Should be T over here. So that would be H, T, T. And then going through tails on the first toss, heads and heads. So that would be T, T, H. Tails on the first toss, heads on the second, tails on the third, T, H, T. And then for the last 2, T, T, H, and then T, and T, and T. How many possible outcomes are there in this experiment? I'm going to count them. I'm going to count the numbers, the outcomes that I wrote out. 1, 2, 3, 4, 5, 6, 7, 8. So 8 possible outcomes. Eight outcomes. Now, for each of those outcomes, I can find the probability. So the probability of getting heads on the first toss, what's that? 1 over 2. 1 over 2. Probability of getting heads on the second toss, 1 over 2. Probability of getting tails on the second toss, 1 over 2 as well. Probability of getting heads on the third one, 1 over 2, 1 over 2. And I could do the same thing, write the probabilities of getting a specific outcome along the path. So over here, if I want to go this path, tails, heads, tails, I would write 1 over 2 for tails, 1 over 2 for heads, and 1 over 2 for heads. So then, the last thing for the 3 diagrams that I need to recognize is to get the probability of a given outcome. So for instance, getting probability of heads, heads, and heads, all I need to do is take a look at probabilities along the path and then multiply them together. So that would be a half by a half by a half. similar to what we did yesterday. So that's a half by a half by a half, and that equals to 1/8, which kind of makes sense because what is the number of sequences that show heads, heads, heads in my list? There's just one, just this one over here, and the total number of sequences is 8. So that's the probability of 1/8, matches what we know about getting the probability. And now we're going to do a couple of examples. Let me finish